So here's my last example here with using dynamic memory and pointers. All right, so suppose we have an array and we're not quite sure how big we want it to be. And so one of the nice things about using pointers and dynamic memory is that we can create or destroy an array at runtime. So the advantage here is that we now have the ability with pointers and dynamic memory allocation to have arrays which are variable in size, and that could be very useful. So let's try and do a little example that will show how to use dynamic memory arrays. And let me create again, I'm working with integers, but recognize this could be used for other data types as well. So let's create a pointer n, and let's have another integer called size that will allow a user to input different sizes of arrays. And then lastly, anytime we work with arrays, it's always nice to have an integer that will allow me to iterate through it. All right, so let's start by having the user enter in an array size. And this is something we can't do without dynamic memory. So I'll ask the user enter an array size. We'll get some input. And now we need to dynamically allocate memory. Here's the way we do it. We say n is going to be equal to, and we'll use the C++ reference here, which will be new. We want an integer, and it's an integer array. And our array, how big do we want it to be? Well, it's going to be variable. It'll be based upon whatever the user inputs in for its size. Okay, so we've created that, and I always like putting this in right away so we don't have any memory leaks here, but let's go ahead and delete it at the end of our code here. All right, and in the middle here, we have an array that's of size, well, whatever the variable size is, and so let's iterate through it and put some values in it. So I'll say I equals 0, I is less than size, and increment it at the end. And we'll have to ask the user again here to go ahead and enter some values. We should probably help them out by numbering those. Okay, so we'll say enter value, and maybe we'll use I here. We'll use I plus 1. Okay, we'll output there, make it look nice, and now we want to input in. What do we want to put a value? Well, it's n, and again, it's a pointer, so we don't need to put a asterisk by it because we're working with an array now. So we'll say n I. And just to complete the activity, so we get some output out of this, so we've asked the user to enter in a series of values here, and then let's just turn around and spit them back out. Okay, so we'll use again a loop here, and we'll say, just ask them to send out the values. In fact, I'm going to get rid of all this. We'll keep it really simple here. We'll put a space in there, and we want to see n, whatever's in I. Okay, I think that'll do it. And then the last thing we do is go ahead and delete that memory out. All right, so quick review here. We have a pointer called n, which is going to be a variable size array. Upon runtime, we get the array size from the user in lines 5 and 6, and then in line 8, here's where we dynamically allocate memory. Note the syntax on it. We're going to create an array n. New is our allocation statement, and then we want to have a series of integers that of size, and we use the brackets here. So note the syntax, and then once we have built that particular structure, then we're going to populate it just like we would any other array, and then we'll display it to the screen. the values of those, and then we'll go ahead and delete them. All right. Save. Let's compile now. Now let's run it. So we'll have an array of size. We'll keep it small here. Let's have just a 3-element array, and we'll put in the numbers. Let's put in some odd numbers. 1, 3, and 5. And you can see then after that we'll go ahead and display those. And I'll move this down so we can make this. But let's look at our code. In the code, the first thing that happens is that we're at the array size. Line 8, we dynamically allocate memory for it. Lines 9, 10, 11, and 12, we populate that array. And then line 14 and 15, we'll go ahead and just display it again. Really important, line 16, that we deallocate memory.